everybody, hope you're having a good day. We're going to look at algebraic equations and how they work. So we need to be able to do four things for this to be successful. We need to identify what a linear equation is. We need to know how to use the balancing method. We need to make sure we can solve some simple algebraic equations, and we need to be able to work with fractions. So the first part is let's look at a simple equation. If we add 3 to x, here's x, and the result 7, what must x be? And by trial and error, we can see that x must be 4. 4 plus 3 is 7. Now, that's all well and good doing it using trial and error, but we should also be able to do it using algebra. And that's all this bit over here explains. The method we're going to use today is the balancing method, and it works well with linear equations. It works well with any equations, but we're going to start with linear equations. And we should really know what a linear equation is. So a linear equation is an equation where the highest power of the variable is 1. And in this case, though we don't write it, the highest power of that equation is 1. Now, we can use the balancing method to methodically determine what the value of the unknown is. Yes, we can use trial and error, but there'll be cases where we can't. And it's easiest to start with a simple case. So, how do we do that? Well, if we go down to here, we have our equation 2x plus 1 equals 7. And at the moment, what we really want to know is just what x equals. So we want this line. So we're going to look at this and say, what's there that we don't need? And we don't really need this plus 1 on the left-hand side of the equation. So we want to eliminate it somehow. And the method we're going to use is by subtracting 1 from both sides of the equation. At the moment, this side of the equation is equal to that side of the equation. If we subtract 1 from this side and subtract 1 from this side, they'd still be equal. So let's do it. 2x plus 1 minus 1 equals 7 minus 1. 1 minus 1 will be 0 and thus be eliminated. And 7 minus 1 will leave 6 on the right-hand side. Now we have an equation where we have 2x equals 6. We want to eliminate this 2 so we can get down to just having x. To do that, we're going to divide this side by 2. 2x divided by 2, half of it would only be 1x. But if we divide this side by 2, we have to also divide this side by 2. So here we go. 2x divided by 2 becomes x. 6 divided by 2 becomes 3. Now we've found out that x equals 3. And like we found out before, if we substitute 3 into this equation, 2 times 3 plus 1 equals 7. X equals 3 is a possible solution. Now, once we know what's going on here, we can drop 2 of the steps. So if we look at 2x plus 1 equals 7, we can just say in our head, we want to eliminate plus 1. We do that by subtracting 1 from both sides. Subtract 1 from this side, we end up with 2x. Subtract 1 from this side, we end up with 6. It's a logical conclusion to go from here to here. Then when we look at this line, we want to eliminate the 2. So we're going to divide both sides by 2. Divide that by 2, we get x. Divide that by 2, we get 3. What's important though is that we actually understand what it is that we're doing. This is what we're doing. This is how we show it. So let's do some examples. In this case, we have x plus 8 equals 13. We're going to try and get x to be the subject of the equation on its own on the left-hand side. To do that, we're going to subtract 8 from both sides. If we subtract 8 from this side, we get left with x. If we subtract 8 from this side, 8 plus 5 is 13. We'll end up with 8. 13 minus 5. Sorry, that's not right, is it? We're going to subtract 8 from both sides. 13 minus 8 is 5. There we go. First one done. Second one. In this case, we're multiplying x plus 3 by 4, and the answer should be 16. What value of x will make this true? I suppose the first thing we could do is we could divide both sides by 4. So if I divide this side by 4, and I divide this side by 4, the 4's will cancel. I'll be left with x plus 3 equals 16 divided by 4 is 4. Subtract 3 from both sides, x equals 1. Nice and easy. In this case, half of x take 4 equals 3. So if I double that, I'll get just x take 4. And I'll double also the right-hand side, which will give me 6. Adding 4 to both sides, x equals 10. Now in this case, it's a bit harder. We can either multiply everything by 2, and then everything by 3, and then simplify what we have. Or we could find a common denominator and then multiply. I might do it both ways just to show how it can be done. So if I multiply everything by 2, 2 times a half of x will just be x. 2 times 2x on 3 will be 4x on 3. And 7 times 2 will be 14. Now if I multiply everything by 3, 3x plus a third of 4x will just be 4x. And 3 times 14, 28, 32, 42. Now we can simplify this part. 3x plus 4x is 7x. And x will be 42 on 7. 7, 14, 21, 28, 35, 42. 7 5s, 7 8s are 56, 7 7s are 49. No. 7 6s are 42. So x would be 6. Right, so we've done our first problem. That's one way of doing it. The other way would be to make a common denominator and then multiply that out. And that's probably the easiest method in this case. So multiply the first term by 3 on 3. We'll get 3x on 6. Multiply the second term by 2 on 2, which will give us 4x on 6 equals 7. We'll end up with 7x on 6 equals 7. Multiply both sides by 6. 7x will equal 42. And as before, I might just put a bit more space in here. As before, x will equal 42 divided by 7, which will be 6. Here with this next one, we could eliminate the 3 first. 5x take 3 is just 5x, and we'll end up with 2x take 3 on this side. We've got this 2x on the right hand side, so we'll subtract 2x from both sides. 3x equals 2x take 2x will be 0, minus 3, divide both sides by 3, x equals minus 1. Now those steps are fairly simple, but there's a lot of them. So to get good at this, it really requires some practice. So I suggest we all have a go at Essential Maths 10, 10A, page 17, and do the following questions. Thank you, everyone.